Welcome to This Explainer. Today, we're taking a really close look at the mandatory quality control procedures for threaded reinforcing bars, mechanical couplers, and form savers. Now, if you're managing or working on a modern construction site, you probably already know the incredible importance of these components, but we're going to break down exactly how to get them right. And listen, the stakes here are absolutely massive. Why? Because overall structural integrity relies completely on perfect connections. We are talking about strict, down-to-the-letter compliance with the CSA A23.3 standard for the design of concrete structures, as well as the BC Building Code. These aren't just polite suggestions. They are the absolute law of the land to ensure every single mechanical splice achieves its full code-specified tensile capacity. Getting this wrong? It's literally just not an option.
So before we go any further, let's make sure we're all perfectly aligned on the core definition here. A mechanical splice, or a form saver, is basically a structural connector used to join reinforcing bars together. But the real catch, and honestly the entire reason we're here today, is that it requires incredibly precise embedment to achieve that full tensile capacity. This tiny little connection is basically the linchpin of your entire concrete structure.
So, here is our visual blueprint for today's site walkthrough. We'll quickly cover the code mandate, pre-installation, exact measurements, the installation procedure, site rules, and then we'll wrap it all up with a final inspection. We're going to see exactly how a perfect connection is achieved, right from the ground up. Starting off with Section 1, the code mandate, requiring 100% inspection.
Okay, let's dive into this. Section 2, pre-installation and stencil marking.
This is where the true foundation for a perfect connection is laid, well before a single piece of steel is ever actively assembled in the field. There are 4 absolutely critical pre-installation steps here. First up, you have to verify all bar sizes and configurations against the latest approved drawings. Second, and this is brilliantly simple, it's really our hero tool for the job, is the pre-mark or stencil method. You just use a plastic stencil to apply a highly visible, super durable spray paint mark right around the entire circumference of the bar. That permanently sets your exact required embedment depth. Third, the QC inspector has to take clear photos of these marked up bars prior to assembly. And fourth, you absolutely must segregate those approved materials. You cannot risk any cross-contamination with uninspected steel. Which brings us to a pretty massive question. How deep is deep enough? Seriously, exactly how much thread needs to be engaged into that coupler to prevent a catastrophic structural failure on your job site? And that brings us to Section 3, exact measurements, mandated by Clause 7. Now, it's super important to remember that these specific code values override any standard manufacturer datasheet you might just have laying around the site trailer. Look at the sheer millimeter precision we're talking about here. For an N15 bar, you need exactly 23 millimeters of thread embedment. Got an N20? That needs 27 millimeters. M25 needs 35 millimeters, M30 takes 40, and a hefty M35 bar requires a full 50 millimeters of engagement. And every single one of these has a strict construction tolerance of plus or minus just 3 millimeters. It's actually kind of funny when you step back and think about it. You can have these massive, multi-million-dollar cranes and insanely heavy machinery all over the site, but honestly, none of it means a thing if a single M15 bar isn't perfectly threaded to exactly 23 millimeters. Let's move to and see how this builds in Section 4, field installation procedure. All right, so this is the physical building phase, where the connection is finally executed with that exact precision we were just talking about. There are 3 highly active steps for field assembly. Number 1 is thread cleaning. Both the internal and the external threads must be completely free of dirt, rust, concrete splatter, whatever. 0 debris before mating. Number 2 is full engagement. This is where you thread the bar into the coupler or form saver until that pre-marked stencil line we painted on earlier is perfectly flush with the face of the connector. And finally, number 3 is tooling. You lock it in securely using a pipe wrench or an approved torque tool. So the absolute main takeaway here is that the connection has to be fully seated, flush to the paint line, and tightly engaged.
Shifting gears now to Section 5, site rules and strict boundaries.
We're focusing on the critical jurisdictional boundaries on the job site. These rules exist specifically to prevent dangerous, non-compliant structural errors from happening during the absolute chaos of a busy pour day. There is a very strict contrast in who is allowed to do what. Look at the formwork crew on the one side. They are strictly prohibited from modifying or adjusting rebar. If a form saver needs a minor alignment adjustment just to secure it to the wooden formwork, the formwork crew has to immediately back off and notify the reinforcing team to handle it. Then, looking at the reinforcing team, they are exclusively responsible for any and all steel adjustments. And here is a massive, totally unbreakable rule. Form savers must, never under any circumstances, be unscrewed or rotated after their initial installation. No exceptions.
Almost at the finish line here. Section 6, Final Inspection, the Validation Phase.
Guys, this is the absolute last line of defense right before the concrete actually pours. To guarantee a successful Canadian structural audit, the QC inspector must formally sign off on a very intense checklist. They've got to conduct a 100% inspection audit on every single coupler to ensure full thread engagement right up to that paint mark. They capture post-installation photography as hard evidence. They document the specific building, lift, and pour number. They record the precise location, like a wall, beam grid line, or a door opening. They carefully note the exact bar size and total count, and they verify the specific connector type that was used. It is incredibly thorough, and it is absolutely mandatory.
Which really leaves us with one final provocative thought to chew on. Is every single connection on your site truly ready for the concrete pour? Following these rigorous steps isn't just about shuffling paperwork or passing a routine quality assurance audit. It is about guaranteeing the structural integrity that human lives actually depend on. Take a moment today to reflect on your own site safety and quality control culture. Build safely and build right. Thanks so much for joining me for this explainer.